Good morning, everyone. Thank you for coming. I would kindly ask you to turn on your cameras. Thank you. So, we had a break that lasted for 2 weeks before because we had a holiday on the 23rd of February. The previous time we started to cover DNS, domain name system. So today we are going first of all to refresh our knowledge because we had a break for 2 weeks. Then we will finish this topic and switch to the TCP protocol, Transmission Control Protocol. During the second pair today, we will have a practical task that is devoted to DNS, domain name system. You will code various tasks using Java. So, okay, my dear. So, what we have covered previous time. So, DNS is a part of the TCP IP addressing mechanism. So we studied MAC addressing. This is a hardware address, MAC address, medium access control. We've briefly covered IP addresses. We will definitely come back to this topic. So this is not a human-friendly address, but in principle, it's enough. Right? It's sufficient to use IP and MAC addresses. But we would like to have easy to remember addresses, and DNS allows us to do this. For example, all address space is split into domains and subdomains. Actually, DNS is used for internet, but it's possible to install a private DNS server within any institution. And here is the complete TCP addressing stack. This slide is very important because it plots the complete mechanism which is used in TCP IP to address individual hosts, DNS, IP, and MAC. And today we will finish this TCP IP addressing topic. So, as I told you, and as you probably knew before, all DNS address space is split into domains and subdomains, right? But there is a very important uh, so uh, name. It's actually not a name, it's a dot, right? Which serves as a root for all other domains. So what does this mean for us? This means that a complete domain name here, a complete domain name consists of all subdomains plus dot, right? And when we configure a domain name server, we should use complete domain names because otherwise such domain names are treated as relative domain names. So we also learned that there is, sorry, there is a special uh, organization, international organization that manages first level domains. These are com, org, etc., etc. So country domains and actually country names are standardized. And we can buy any other second level domain and create arbitrary number of third level domains, etc., actually for free if we have a second level domain. So DNS started with simple files, right? For example, hosts.txt. But when internet grew to the scale of thousands or hundreds of thousands of systems, so this file was not sufficient, and we switched to DNS servers, right? Uh, what we have in DNS servers, so the primary thing we have there is DNS zone file. Probably, so someone would like to help me. If someone remembers what's the contents of the DNS zone file, please, we would like to hear you. Who would like to tell us about the contents of the DNS zone file? Okay, I will start and you'll help me, right? So, a DNS zone file consists of records, right? And each record consists of certain fields. Here is the structure of the record, right? First of all, there is name, then TTL, record class, record type, and actually the contents of this record, right? Record date. What is a name? It's outlined here. It's actually a domain name. It can be absolute, it can be blank, and it can be relative, right? If it's absolute, it ends with a dot. If it's a blank name, the record inherits the name field of the previous record, right? It's just a repetition. And if it's a relative, so does not end in a dot, the actual domain name is the concatenation of the relative part with an origin specified at the beginning of the file, DNS, etc., etc. So the other field in this file is TTL. It's very simple. Who will tell what does TTL stand for? Time to live, right? It's an abbreviation for time to live. It's frequently used abbreviation in computer networks. Again, blank, it defaults to a global TTL. If it's a number, right, it's a precise specification of how this record, how long this record should be cached by clients. Record class, it's very interesting, right? We have currently two record classes. Two record classes in internet, and the second record class chaos system. Who remembers from the previous lesson, what does the chaos system mean? Actually, internet is what we are using today, right, nowadays. And the chaos system, it's actually a very old, outdated predecessor of current internet. But so It's here just for history, right? The chaos system. It's a kind of computer science archaeology, right? It's very old system and actually not used. So record type. This is where the actually fourth field goes here. Name, TTL, record class, it's clear because name is a domain name, TTL is a number, how long to cache. Record class always in, right, today. And now we have interesting information, record type. So there are many record types. So on, record type, start of authority, host address A for IP version 4, the canonical name of LS, CNAME, MX, NS. It's better to cover them when we go to an example, right? It's easier to describe. And let's see here example. Do we have saw? Right, we have saw. What else? A, do we have A here? Yes, we have A, right? CNAME, do we have CNAME? Yes, we have CNAME here. Do we have MX? Yes, we have MX. And lastly, do we have NS? Right, we have three NS records. So, for example, who would like to tell us what uh, is the purpose of the DNS record of type SAW, start of authority? Here it is, the first record, SAW. Okay, I would like to give you a hint. First of all, uh, first of all, this is the complete domain name, right, which you bought. Here is the serial number of the whole, right, DNS record file. Serial number usually consists of year, month, day, and revision number. And the serial number so represents the current version of your DNS configuration for this domain. So if you have a serial number, and if you cached something, so when you receive another serial number, and if it's not equal to the previous serial number, this means that you should repeat caching this DNS file. So what's the purpose of this SAW then? Okay, SAW is used mostly for automatic purposes. What does this mean? So this means that uh, so DNS servers, right? They mostly hierarchical, and also DNS servers can be installed within your organization, and DNS servers exchange data, right? For example, if you would like to go to example.org, your local provider may cache all this data and may not, so query the DNS server for this example.org, right? So in other words, uh, for example, I have example.org mapping to IP. So, right, I would like to cache this, right? All of this thing. Then I use SAW to find out how long should I keep all these data in cache, right? And I would like to have a mechanism to check how to invalidate my cache, right? And this is just the email of the administrator. It's usually never used, right? Etc., etc. So, okay, then let's go here. We told that the record consists of name, TTL, record class, etc. So here I don't have name, I don't have TTL, I have record class. What is the name and what is the TTL for this record? Guys,
Ну, по умолчанию.
and what's the default?
Вторая строчка.
Right, TTL and name. What about name? And name we take from where? From the previous record, right? So the name coincides with this name because this is the previous record, right? Name, TTL also absent here, right? So, etc., etc. So, what's this? These are name servers for my domain, right? Here, the same situation. Name, we take it from here. TTL, we take that from here. And we have the same record type. Please pay attention never chaos, right? Because chaos is not used. And here is a command which starts from the semicolon mail exchanger mx. So 50 mx1 mailcom. What is 50? Is it TTL or something else? What do you think?
Maybe port?
No, this is the priority, right? If we had several MX records, right, we could have, for example, 10, 50, etc., etc., and the number is the priority, right, of the mail server. So actually, if I would like to send an email to, right, example org, right, I first have to discover which mail server is responsible for managing the mail for this domain. How do you think why it's required? This is required because, for example, you buy a domain from one provider and you buy mail servers from another provider, right? And these things can be totally different. I will show you in a couple of slides how it's configured for High School of Economics, HSE route, right? Because mail is sent to HSE route or EDU HSE route, but Microsoft is responsible for handling this mail. As you know, we have Microsoft Mail. So, and this means that if I send the mail to EDU HSE route, it goes to a Microsoft server, right? I will show this example in a couple of slides. So finally, this is the complete domain name, example.org dot at the end. TTL, it's here, right? Internet. A, what does this mean, A, guys? It's the most basic record. So we have IP address here, right? This is the mapping of DNS to IP. And here CNAME the last record because we have the end file. So it's a relative record, right? 3W. So it goes so to be concatenated with the previous name. It becomes www.example.org. And please pay attention, the same IP address. This means that if I type example.org in the browser or 3W example.org in the browser, I will be redirected to the same IP address. And in my browser, I will see two different names, right? But they will be associated with the same IP address. That's it. Questions? Okay, no questions. Good. We also covered previous time that we have DNS root servers. There are 13 dedicated names, 13 IP addresses, and each name and each IP address is a cluster of servers, right? I showed you this map. Everyone knows. So these names, these IP addresses, and so if your PC doesn't have a DNS record in its cache, if your internet provider doesn't have such a record, it will go to the nearest DNS server backbone. And we finished actually here. We didn't cover this slide. Actually, this slide was the last, right? Previous time. And it tells us very important information about the procedure. How DNS name is resolved. So there are authoritative responses, and non-authoritative responses. And there are two types of procedures, recursive procedure and iterative procedure. So what does this mean, authoritative response? Authoritative response, this means that we queried a certain DNS server. This DNS server is responsible for this DNS zone, which we queried, and it returns the information about this DNS zone. So authority, right? I am responsible for this zone and I return this authority response. So a non-authoritative response is when DNS server just cached this data, right? For example, using SOA, start of authority, this thing, right? And it can also answer your request, but this response is not authority. And two types of procedures, recursive and iterative. So what does this mean? Recursive procedure is used almost everywhere on your local DNS servers, on your internet server providers, etc., etc. And iterative procedure is used to query root servers. Why? We have root servers, right? They have very high load and they do not query any other service. So how the procedure looks like? I am a client. I query mail1kentoza.com. This query becomes recursive because local DNS server is not aware of this address. So it goes to recursion. It queries a forwarder in your organization, right? Which is a dedicated machine to query, right, external servers. So, and here, if this query is recursive, right, I go here recursively, So the procedure of querying root servers is not recursive, it's iterative. I ask here, do you know .com? Ask com server IP address, certain IP address, which is responsible for com. Then I find this root DNS server and ask for Kentosa.com. This server is not aware where Kentosa.com so is located, and this server does not query any other server, right? It doesn't go recursively because it's too high load on this server. Here we have recursive, and here is iterative: ask response, query response. And now I finally reached to this DNS server, which is aware of Contosa.com, and I get authoritative response, and I go up from the recursion. I return from the recursion here, right? So recursive, iterative, authoritative, non-authoritative, right? Do you have questions? Okay, if no questions, that's great. Let's switch to so the new material, right, regarding DNS. So there is a popular tool called Dig, right? Dig is installed under Linux. So I don't know whether there is a Dig tool under Windows, but probably there is. So what is Dig? Domain, it's an abbreviation that stands for Domain Information Grouper. So it's a flexible tool for interrogating or querying or probing, right, DNS name servers. So Dig has a lot of functionality, just tons of functions. Dig can, for example, Dig can perform DNS lookups, right, and display answers that are returned from the DNSs, right. Moreover, it's so popular tool that even DNS administrators use Dig to troubleshoot DNS problems because of its flexibility, ease of use, etc., etc. So let's cover what we have here, right, in Dig. So if you just print, type Dig, right, you will have these ABCD, right, 13 name servers, root name servers. So where you can query any other domain, right? Let's go here. This is the version, right? Answer, operation code query, status no error. Please pay attention, answer 13 name servers. And here is the list. So this is the simplest answer. Let's go, for example, further. If you query a certain, for example, DNS server, for example, arootservers.org, you'll find another interesting information. You will find, so for example, CNAMEs. Well, what are CNAMEs? This is the association of this, right, with this. And actually, this is an organization, right, which manages this name server. And you will also find, so how to map this again, you see, this is the repetition, to IP addresses, right? For example, even this simple single DNS name can be mapped to several addresses, right? So, and you may query any IP address and you will get the same functionality. Okay, dig. So if you pay attention, there is opcode, flags, query, answer, etc., etc. Dig utilizes DNS protocol, right, to work with this. Previous time, for the first time, we saw a similar specification for DNS protocol in ARP, Address Resolution Protocol, right? And here is another standard DNS message format. It's an internet standard, RFC 1035. And be prepared to that every protocol is described like this. For example, TCP is described similarly, right? ARP is described similarly. UDP is described in this way. So what's the way of description these protocols? So the first thing a standard specifies is message format. Do you remember the definition of a protocol which we gave at the first lesson? The first is message format, right? And then the rules, right, to exchange these messages. So, for all domain name servers, so all messages are, so you use the same format. The same single format. We have 5 sections, right? Header, question, answer, authority, additional. These sections may be empty. For example, if we send a query, so we will have empty answer, right? If we answer, we will have empty question, right? And we may also have empty additional, right, and other fields. So as you already guessed, question is the question, right, for name server. Answer is the answer. This is so a pointer toward an authority. We will look at it a bit later. And it's additional information. So what's distinct here? Header is a special format. We will cover it next slide. Question is also specially formatted. And please pay attention on answer, authority, and additional. These are all lists of resource records, RR resource records. This is the list of resource records, this is the list of resource records, and this is also. So, as you probably already guessed, the header is always present, right? And the header just specifies which other sections are present, right? And whether the message is a query or response. So let's look here. Here is the header. Oh, I'm sorry. Here, header fields. As usually in all protocols, we mark the bit number, right, from 0 here to 15, right? This is a word, 2 bytes. And first is ID. ID is generated by client, and so it's arbitrary number. How do you think why ID is generated by a client? For example, Roman, why? What do you think? No ideas.
Нету.
Okay. Who has any ideas? Okay. So to answer this question, let's imagine how the procedure looks like. For example, I'm a client and I would like to resolve several DNS names. For example, CNN.com, HSC.ru, and what else? So GitHub.com, right? To resolve these names, I can first, actually DNS allows to put several questions, right? But if I send separate messages, right, in time, and these messages travel somehow to the DNS, they may travel and may arrive in different order. For example, I query CNN HSC GitHub, and DNS server will receive GitHub CNN HSC. Okay, DNS server will respond the names, but these will travel to me to as client also in different order, right? The response section will contain, well, actually what may contain what I have queried, but to so quickly find and to quickly match query to response, client uses IDs. For example, I set ID 0 to query HSC, I set ID 1 to CNN, and I set ID 2 to GitHub. And when I will receive, right, responses, right, I will match IDs with responses. That's it. So then I have a single bit, whether it is a query and whether it is a response. So if it's a query, answer section is empty. If it's a response, right, the query section is empty. Then operation code, it's a standard query, inverse query, etc., etc. 1, 2, 3, 4 bits. Then other indicators, flags, right? 1, 2, 3, 4 flags. Z as future use, it's not used, but what does this mean? Authoritative answer. This DNS is responsible for this domain name. So truncation, what does this mean? This means that this message size was larger than 515 bytes over UDP. Right? RD, recursion desired. When we query, recursion desired is mean if this DNS server supports recursion, right? Please use the recursion. RA, recursion available. That's actually kind of a flag which is set during the response. And R code, response code. No error and other error codes. And then counts, QDANNSIR. The number of entries in the question section. As I told you, I could query, for example, HSE, CNN, and GitHub in a single message, right? But I can query them in different messages over the time because I don't want to wait when other people will query something I need to resolve immediately, right? But if I have a lot of DNS names to resolve, I can put them into a single message. And ANNSR, the number of resource record in the answer, authority, and additional sections. Right here, answer, authority, additional. And because we have word here, a lot of information can be packed in a single DNS message. So let's cover DNS question section format. Well, this section actually carries questions, right? QD count entries. First of all, Q name is the domain name, right? Is a sequence of labels, right? That consists of a length octet, right? First, you have here length, and then the number of octets. So you code just the domain name as a string, which precedes with a number of symbols there, and actually the symbols themselves. So the domain name terminates with a zero length octet for the no label of the root, right? So if there is an odd number of octets that is not divided by 2, right? For example, 5 or 11. So, so no padding is used, right? Because we have the length here. And the other additional fields is just Q type, query type, MX, NS, AAA, what I want. I want a mail server here. I want just a mapping, etc. And this is a simple field which specifies right, the type of the system, and it's always internet right here. Resource record format. So the answer, authority, and additional sections all have the same format. This is the format, right? This is a variable number of resource records where the number of records is specified here in the count section, right? And all these sections have the same format. Here it is, right? It's standardized format. It's just the same as the resource record format for the zone file, but just a binary representation, right? It's just bits, right? Not symbols. Here, name, domain name, right? Type, right? You see class, internet, right? Always one. TTL, the length of data and the data itself. TTL is a 32-bit, you see, TTL is thick here, right? So it's a 32-bit unsigned integer in seconds. It specifies the resource that the resource record may be cached before it should be discarded for this number of seconds, right? And zero values is this means that this error can only be used for the transaction in progress and should not be cached, so never cached. Very simple. It's a lot of information, but you already know this information because we covered DNS name. So some practical usage of DNS. So, for example, a record. Say you buy a domain mycompany.com, right? And you would like to create a blog mycompany.com. So you have this domain name and you can create an arbitrary number of subdomains here, right? It's a very practical example. You may encounter it in a daily practice. So in this case, you do not need to buy an additional domain. It's very important. and you rented a VPS with a certain IP. What does this mean? Virtual private server. So you rented a virtual private server, you would like to host your blog, right, with a certain IP. So this domain name is bought from one company, the other domain name, so IP name, IP address is bought from another company. So you would like to host a WordPress site on your VPS. How to configure DNS? So you just go to an administrative panel of your domain. You don't need to configure a DNS server on your own, and you create a record. You create a record something like this: blog my company.com in A, and it maps to your IP address. So if you have cPanel, for example, which is provided by most name providers, you just go to zone editor in cPanel, right? And you have zone records for your domain. You just click add record, right? And you create record something like this, right? You specify TTL, you specify A, and you map that to the IP address of your VPS. Right? It's very important, very, very easy. So the second example, the second practical example. So MX records are used to tell where to send mail to you, right? There is a standard, RFC 5321. SMTP clients must look up an MX record, right? They can send a mail just to that domain name you provided, right? So if and only if no mixed record for the domain is present, so treat the domain as if it had an MX record with the given domain name as the target host name, right? So an email message system will send mail to this domain only if there are no MX records, right? And then if it retrieves an MX record, right, it will perform A or AAA lookups as required to determine the IP address of the target host name. So it's not enough to extract an MX record because it will also contain a domain name. So again, you should extract an IP address, right, for this domain name. Here is the example. So we can use a dig tool, dig eduh0, and I need type of MX record. This is just the version. So got answer, opcode, query, status, no error, ID was generated by the dig, flags, recursion, etc. Recursion available, one query, one answer, authoritative answer 0. So let's look. Answer. So eduh0, full domain name, right? This is the TTL, 60 seconds, internet, mail record, right? And here is a very interesting thing. Look, 0 is a priority, right? And then a lot of numbers, .mail.outlook.com. How do you think? What does this mean? Any ideas?
Может быть, это почтовый ящик?
So we are dealing with, it's close, right? Your answer is close, but we are dealing with domain names, right? Yes, very close, very close. So good answers, guys. So what does this mean? As I told you before, edu HS0 as well as HS0 is served by Microsoft, right? This is a cloud mail, right? And we have, first of all, a way to redirect mail to Microsoft. This is using the MX record because High School of Economics buys Microsoft service. Here is Outlook.com. And what is here? So it's a kind of a load balancing, right? A lot of mail goes here, right, to mail Outlook.com, and a lot of MX records should be here, right? Probably with different IP addresses. So the first step of a mail system, it discovers this. And the second step of a mail system, it would like to issue the same query here, right? Dig and this string to discover the mapping to the A, right? To IP address. That's it. So here it is, the second step of a mail system. I would like to dig this one. And the answer section is like this. Here is the name, actually two names, time to live, even less, 10 seconds, you see, right? And this is a mapping to the IP address, two different IP addresses, right? They differ by 4 and 6 here. So you're currently, if someone sends a mail to eduh0, it will send email to mail system which is located here or here. That's it. So many things. And I will now show you in action. So win pcap and this dig. So let me, so any questions, by the way?
У меня вопрос, на самом деле, на каком протоколе вот происходит передача сообщений DNS?
It may go in UDP or it may go in other protocol. I will show you. Сейчас покажу на практике. Ну, давайте тогда сейчас, значит, начнем с... Так, ну вот у меня есть, допустим, соответственно, машина. I have a machine, right? Сейчас я зайду туда. I have a machine with Linux. Так, у меня есть машина с Linux, VPS. Here it is. Again, we may repeat actually this thing. For example, TMX. Let's check what's now, right? A very different thing, да, совсем другая вещь. То есть теперь вот именно сейчас, в данный момент, 3600 секунд, да, вот на протяжении будущих 3600 секунд вся почта, которая идет на EDU HSERU, должна посылаться сюда. EDU HSERU Mail Protection Outlook.com. Да? А давайте посмотрим, если у нас почта на HSERU, да, бывает у сотрудников почта на HSERU. Хорошо. Теперь вся почта, которая идет на HSE.ru в течение 60 секунд должна посылаться либо сюда, да, либо сюда. MS Frontend Microsoft, да, Frontend HSE.ru, или вообще что-то не связанное с HSE.ru, да, вот сюда. Соответственно, мы можем, да, вторая фаза почтового сервиса, он же не может посылать почту, да, вот прям туда. Он должен найти IP-адрес, да, вот этого дела. Так. Нашли. Вот, собственно, IP-адрес теперь, по сути дела, куда посылать почту. Это вот этот IP-адрес. Вот так, в общем-то, действуют, да, почтовые, собственно, клиенты, если мы говорим о почте. Теперь, что касается протокола, да, который используется для передачи DNS, да, но и всего остального. Форматов, заголовков. Здесь мы, соответственно, открываем наш любимый Wireshark, да? Так. Вот. Пожалуйста. Ну вот эти UDP протоколы, это, скорее всего, я с вами разговариваю. Нам может как бы понадобится, да, понадобится фильтр, мы вводим DNS, да, но пока ничего не происходит. Давайте попробуем, соответственно, что-то запросить, да. О, пошло, я вот браузер открыл, да, пошло куча, соответственно, DNS запросов, DNS ответов. Давайте посмотрим. Mail google.com, ну вот, например, да. Вот как я и говорил, да, у нас запаковка иерархическая, да. Начало идет DNS, да, DNS запаковывается в UDP, да, UDP передается по интернет-протоколу. Это все в фреймах, да, которые мы с вами уже учили. Давайте начнем с того, что мы учили, да, ну вот, например, Ethernet 2. Это вот тот фрейм, по сути дела, который поймал Wireshark. Что у нас здесь? Источник мой ноутбук на Samsung E, приемник мой роутер, который установлен, да, провайдером. Тип. О, какой интересный тип. IP-версия 6 даже уже используется. Да? Теперь интернет-протокол. Мы его еще не учили, да. Датаграмм очень простой, мы его немножко позже рассмотрим. Но здесь все очень просто на самом деле, да. Порты мы тоже не рассматривали, мы будем рассматривать, когда TCP. Да, будем, значит, источник, да, 53-й порт, это порт DNS сервера, 41, соответственно, длина, да, содержимого, чек-сам, да, контрольная сумма, как и везде. Да. И вот 33 байта, собственно, запросик. Ну, давайте посмотрим. ID. Кто помнит, что это такое? Вот мы сегодня рассматриваем. Не выспались, да? Правильно, да. Transaction ID, код, который генерируется клиентом. Посмотрите, флаги потом дальше идут, да, которые у нас, по сути, кодируют поведение, да, но они как бы являются рекомендательными, да, то есть они не значат, что DNS-сервер будет так себя значит, ввести. Первый флаг это является response или не response. Да? Сейчас это 0, потому что это сообщение является запросом, query. Да? Код операции, обычный запрос. Да? Сообщение не обрезано. Почему? Оно помещается полностью в один, скажем, датаграмм, да, в одну датаграмму UDP протокола. Да, рекурсия, как бы желательно. Но это не значит, что DNS-сервер будет что-то делать. Да? Это зарезервировано. И здесь пока не имеет значения authoritative response, потому что это запрос. Да? У нас всего один вопрос. Ресурсные записи ответа отсутствуют, потому что это запрос. Authority Resource Record отсутствует, потому что это запрос. Дополнительные отсутствуют. И вот список запросов. Мы можем несколько запросов отправлять, но на самом деле сейчас пока здесь всего один запрос. Да? Открываю. Как он выглядит? Он выглядит, в принципе, в точь-в-точь, значит, как было у нас на лекции. Да? Имя, 3 вещи я запрашиваю, тип и класс. Класс у меня всегда интернет. Оказывается, я запрашиваю IP-версию 6, да, 4А. Если бы был 1А, я бы IP-версию 4 запрашивал от IP-адреса. И я запрашиваю DNS-адрес тройное www.gstatic.com. Давайте посмотрим response. Ну вот response интересный сервис. Вот, допустим, я использую Calendly. Да, вот сервис Calendly.com. Да, вот очень интересный сервис. Давайте посмотрим, что здесь. По сути дела, ID то же самое, да. Флаги теперь у нас немного поменялись, да. Во-первых, их больше, да, стало, потому что больше единичек. Первое, response, да, response, единичка. Opcode был стандартный запрос. Да. Authoritative, то есть является ли ответ закэшированным, либо мы добрались до того DNS-сервера, который ответственен за Calendly.com. Нет, мы добрались до кэшированных данных, скорее всего, это в интернет-провайдере, это все закэшировано. Да. Сообщение не урезано, да. Рекурсия желательно была и была доступна, да, зарезервирована и так далее, то, что уже неинтересно. Нет ошибок и так далее. Был один вопрос, да, 2 ответа целых, да, и дополнительные записи отсутствуют. Первое отсутствует, потому что это не authoritative response, а вторая, потому что нет необходимости. Queries. Продублировали запрос на всякий случай, да, бывает, да, мы дублируем запрос. То же самое все, по сути дела, что я запрашивал, IP-версия 4, интернет. И ответ, то, чего мы еще не видели. Да. Ответ – это список ресурсных записей. Да. Query, answer имеют абсолютно, да, одинаковые, собственно, вот, смотрите, name, ресурсная запись. Name, тип, да, какой. Класс, in всегда один и тот же. Time to leave, аж 5 минут можно, да, кэшировать. Размер данных 4, да, байта. И вот наши данные. 4 байта, IP-версия 6. Соответственно, так выглядят, да, запросы. Может быть, здесь еще что-то интересное можно Это запрос. Это mail google.com. Смотрите, сколько ответов, да, раз 4 штуки. Ну, в общем, как-то вот так вот работает DNS-протокол, да. Абсолютно все я вам как бы о нем рассказал, ну, как рассказал для того, чтобы понимать с точки зрения программной инженерии, как им пользоваться. Да? Давайте вот немножко повторим, например, практические моменты. Вот я не знаю, я не рискую, может кого-то спросить, кто хочет, чтобы его спросили, чтобы он проснулся. Вот, ну хорошо, может Владислав, да, может хочет. Владислав, очень простой вопрос, просто если вы слушали. Вот вы купили новый домен, да, допустим, компания.com, да. Вот что вам нужно сделать, чтобы развернуть, значит, на каком-то сервере, тоже купленном, blog.компания.com, чтобы DNS-адрес blog.компания.com перенаправлялся на тот IP-адрес сервера, который вы купили. Вот как это в общих чертах можно даже.
Ну, вы показывали, можно на каком-то сайте добавить запись, которая перенаправляет вот этот
То есть,
blog.compania.com на какой-то IP.
да, то есть, если ваш значит, регистратор, да, у которого вы купили компания.com, значит, предоставляет какой-то интерфейс, да, обычно это cPanel называется, то, по сути дела, вы можете зайти на этот cPanel, не трогая DNS-сервер, и в этой cPanel ввести запись типа А, да, то есть если это IP-версия 4. И у вас blog.com, да, blog.компания.com, тип записи А будет перенаправляться на тот IP-адрес. А соответственно, если у вас нет этого интерфейса, если вы сами налаживаете доступ DNS, что очень редко, вам нужно просто зайти тогда на DNS сервер свой, да, ресурсную запись создать, то же самое, да, как бы с помощью вот этого, так скажем, интерфейса cPanel. Но обычно cPanel везде предоставляется. Как-то так. Вот. А вот, может, нам расскажет Новин, вот что предпринимает клиент, который хочет послать, например, почтовое сообщение по электронной почте на адрес, допустим, ну вот даже тот, который мы рассматривали, HSE.ru. Какие его шаги?
В смысле шаги вы имеете в виду, ну, что лежит в основе этого?
Ой, плохо слышно что-то.
Да, не слышно, нет?
Слышно, но слабо так.
Странно. Ну, шаги в плане, что происходит, когда он...
Ну да, вот как вы понимаете, что вы запомнили просто из этого?
Ну, у нас идет, получается, тоже мы по какому-то адресу. Сейчас.
То есть сначала вот, да, значит...
Мы определяем сначала, да, адрес, по которому будет отправляться.
Мы определяем сначала доменное имя, да, которое назначено серверу почтовому, да, это MX-запись, это первый шаг. А потом это доменное имя мы должны отобразить в IP-адресе. Второй шаг, мы опять обращаемся к DNS, да, которое нам возвращает по данному DNS имени сервера уже IP-адрес. То есть 2 шага, правильно? Вот.
Ну да,
Хорошо.
окей.
Хорошо. Ну вот, с точки зрения программных инженеров мы понимаем, в общем-то, форматы, да, процедуры. Мы понимаем виды запросов, да, рекурсивные, итеративные. Мы понимаем от начала до конца, как это идет. От корневых серверов, да, и может кэшироваться на уровне провайдеров и так далее, и так далее. То есть, еще раз, вот, допустим, просто повторю ответ на вопрос, который был на прошлом занятии. Вот полностью чистая машина, полностью только развернулся провайдер, все сервера чистые. Да. Выполняем DNS-запрос, этот DNS-запрос идет к провайдеру, провайдера нету кэша, да, он еще пустой. Идет запрос на ближайший корневой сервер, да, географически. Потом, пока ответ идет нам назад, он кэшируется на всех уровнях у провайдера, даже у нас на локальной машине. Да. Соответственно, в следующий раз, когда мы выполняем DNS-запрос, происходит обращение уже в кэш, да, того же провайдера. DNS-сервера благодаря записи SOA могут обмениваться, да, ресурсными записями, и не обязательно искать, да, в кэше что-то или обращаться к кому-то, можно просто скопировать очень много всего, да, на свой DNS сервер вот, с помощью SOA. Ну хорошо, большое спасибо, что слушали, что пришли. Следующее занятие мы еще более, вот сейчас, через некоторое время, еще более углубимся, да, в, соответственно, DNS и попрограммируем. Да. Поэтому большое спасибо, жду вас.
В следующем занятии нужна идея, да? Я тогда с компьютера перезайду, а не с телефона.
Да, да, иначе не сможете программировать.
Да, хорошо, тогда сейчас произойду.
Так, ну, счастливо, приходите.